Welcome to the AI with Alaa podcast. This is the podcast where we create substance about AI rather than create content. This is episode 13, and my guest today is Daniiar Abdiev. Daniiar, welcome to the show.
Thank you.
Daniiar, you are the head of AI and generative AI at Talabat. You are also a founder of Mascara, an AI agentic and context engineering company. And you're at the heart of all of it. You are a builder, right?
Yeah.
Tell us about your building journey pre-AI and what were you building when the dawn of AI arrived?
Yeah, sure. So, right from the university years, well, first of all, the entire journey was inspired by AlphaGo, actually. So I saw the video, and I was like, because before I was working as a backend engineer, but then I saw on YouTube how Licedo lost into AlphaGo, and I knew from my software engineering days that the Go is extra hard problem to solve with traditional methods, which are brute force. It's just too many combinations. And then when AlphaGo won, I was like, okay, this is the field where I need to be. So I moved from software engineering to machine learning, and I started doing traditional ML. And then from there, I started doing NLP. And from NLP to LLMs, and now I'm focusing mostly on the Gen AI stuff.
Amazing. How was it for you when the Transformer paper was published in 2017? Were you then doing traditional ML, or were you already doing NLP and following NLP closely? And what was your first impressions about this paper?
Honestly, I just skipped it. I didn't up this where like read it and I was like, okay, this is the one. I kind of skipped it. I had to come back to it once transformers were used everywhere in LLMs and so on. This one I had to come back to it. So I definitely didn't have this vision that this actually makes a lot of sense and is revolutionary. So yeah, this is.
To be fair, nobody thought it was revolutionary. Even the big names working in AI went back to it after the fact. After the GPT moment, everybody flooded to read the Transformer paper. Before that, it was flying under the radar. What was the in generative AI? So we know that in AI, the AlphaGo moment was the aha moment for you. What about in generative AI? What was the big aha moment for you?
For me, GPT-3, that was the biggest one. Like GPT-2 was already pretty powerful, but still was making quite a bit of mistakes where it was difficult to imagine the world where we wouldn't be writing code like today, for example, when we very would write code, or the world of agents and automation. But when GPT-3 came out and it was behind the John Wick list, was one of the first people to get access, and as soon as I got access, I started playing around with different prompts, and you could just feel that it's order of magnitude better than anything before. And to me, that was the hammer. It was like, okay, this actually works. The also scaling actually work. So, yeah.
Amazing. And since then, obviously, ChatGPT was launched on November 30, 2022, took the world by storm. So then the genie got out of the bottle. It's no longer just inside the developers' rooms or developer circles. It's mainstream. And since then, the rest is history. Gen AI has exploded exponentially on the world stage. Take us through the last 3.5 years since ChatGPT was released, throughout all these different releases till today, when we have, I think the state of the art is Claude Fable 5 or Opus 4.8 before Fable 5. What were the main milestones that you thought were a step increase in capability from ChatGPT 3 or 3.5 till today?
Yeah, sure. It's actually funny, but when ChatGPT came out, I didn't see it as something incredible. Though the only thing that I thought about is that it's a smart interface. To me, that was the only change, because GPT-3 was before ChatGPT. It already could do all of those things and really well. The only change that I saw was the fact that you could do follow-up questions, and the prompting for GPT-3 was mostly based on few shots where you would provide examples, and whatever your next example would not have output, and this is the GPT-2 would provide the output. But here, because they tuned it more for conversational user interface, it became more available for everyone else. And as far as I know, they didn't even expect themselves that it will blow up as much. They kind of released it as a research project, and then everyone really liked it. Simply because the capability was always there, like for at least 6 months before ChatGPT got released. So to me, ChatGPT is really this. So in terms of what you're asking of order of magnitude change, right? Step change. ChatGPT is a step change, but in terms of UX, not in terms of technology. And when we talk about technology, starting from ChatGPT, I think to me the next step change was when multimodal models get released. So I think those GPT for all, I believe this all for only, yes, where one neural network handles all those different inputs. That made a lot of sense to me from 2 points of view. So first, I think, again, it is a huge UX improvement for users. You now upload images and then you analyze them. But then the second is that you now have a ability to train your neural network without losing information by converting one data type to another data type. So before, you would have to convert all of those PDFs and images into some sort of textual information and then feed it to your network. And of course, there would be a loss of signal. Here, you just feed it directly, and that improves the mobile performance by a lot. So that was another step change. The next one, I think, is real-time processing.
Yes.
So when GPT released the real-time, so like, okay, that's incredible. Interestingly, though, I do think that the UX wise, it's amazing, but people didn't really adopt it as much. I just think it's not necessarily because it's a bad UX. I just think that we're just not there yet. Just like these Google glasses, we keep reinventing the same thing for quite some time, but I think we'll get there at a certain point. And then after real time, it's probably Sonnet from Claude that really changed the way we do coding. And then from there was Anthropic really doubling down on coding, which back then didn't make that much sense to me, because I thought that the future is to invest into multimodal, to invest more into this problem of data. But turns out it was actually really good, but because now they are talking about this self-recursive system where that just improves itself, right? Because if you can create a model that's the best at writing code, then it just writes itself and makes it even better and better, and so then ultimately it becomes the optimization problem that's just the function of capital and time. So that was very visionary from whoever made this decision.
I agree. I mean, their strategy was, we have, back then, they were much smaller than OpenAI and much less funded than OpenAI. So they had to choose their battles.
Yeah.
And they chose, we're not going to do a million things. Like OpenAI is doing Sora, and they're doing a million other things. And they're doing B2C. And we're only going to do B2B and coding in particular. And if we solve coding with a lot of reinforced learning, then a super coding agent can build anything for us and can accelerate our path to AGI. And I think that's what put them in the pole position today. And it's fascinating, and throughout this story, we were talking, me and you, before we started recording, about the discrepancy between who is using AI the most today, which are developers, while at the same time they are a small minority of the workforce. And this big, this means there's a big opportunity for AI in the workplace. Tell us more about this and about your thoughts around it.
Yeah, so there was this chart circling around Twitter for quite some time now that basically shows that among all AI agents deployed in production, by far the majority of AI agents have to do something with coding and coding optimization. But if you put this contrary to the actual workforce distribution, most of the work is not coding, like it's less than 1%. So you would think that this AI application would mirror the actual workforce application, but it doesn't. It's super biased towards coding. And if you think about it, it makes a lot of sense. Engineers are first early adopters, so that's why it's happening. It's not happening just equally. It happens depending on early adopters, and the engineers are early adopters, and that's why it's happening. However, if you kind of remove this and think about truly the future, obviously AI will replicate the workforce distribution. So whatever majority of people are doing day to day, AI will be doing it in the future. So it's just a matter of time until applied AI will catch up to what theoretically is possible already today.
Really? What do you think that the missing bridge is for non-coding knowledge workers to start adopting AI and building agents with the frequency and the speed that coders are doing it today? What's missing?
I honestly think that the main kind of gap that we need to bridge is UX. So if you solve user experience for non-technical users, you'll be able to solve this problem. And the reason why I believe in this is because even with developers, just recently, right, I think it was in February or January when there was all this hype about OpenClaw, and then later Hermes agents and so on. This capability of calling tools and so on was there forever. Everyone had this. But still, developers apparently didn't know about this capability because no one clearly was building their own open cores. So as soon as OpenClaw came out, they're like, oh my god, it's so powerful. But it was there all this time. And the guy who created OpenClaw just put it all together in a very convenient way. So what he solved was a UX problem. That therefore, I believe that for non-technical users, you need to push even harder to solve this UX problem. And if you do it, then the gap will be slowly solved. So that's one thing. And then the other gap, I think, is also just a mental model knowledge gap. Because if you think about it, probably in the 90s when everything was just starting out, internet revolution, not a lot of businesses even were thinking about whether they need a website at all, and what for, or what is a website, or how it should look like, and so on. And if you ask right now a random person, like, hey, I will create an AI agent for you, you don't even need to. So UX problem consider it done. Like, I'll just make it for you. What kind of AI agent do you want me to build and what for? I don't think many people would be able to even picture it or say what needs to be automated. This cold start problem still exists simply because majority of people don't have this mental model around what the agent is or like in 1990s, what the website is. And this will be solved only over time as popularity grows.
Brilliant. I think part of the problem, first of all, I agree with you that these two, the UX problem and the mental model problem, are the gaps. I would add a third gap, which is the subject matter expertise. When I advise to startups trying to build an AI for ... fill in the blank subject matter, I find that usually there are two co-founders, if both of them are coming from the AI world, chances of success are low. If both of them are coming from industry, chances of success are low. If one is coming from AI world and one is coming from industry, chances of success are high. It's a general heuristic. I think currently most agents are in coding because it's the same person. The AI expert and the subject matter expert is the coder. But when you want to create AI for retail, AI for banking, AI for compliance, AI for legal, you need this combination. So you either need to solve this by creating a self-use UX to subject matter experts, or you need this combination of the AI expert and subject matter expert.
100%, because you simply, as a coder, as a builder, you simply don't know what problems there are. Like, I don't know what problems lawyers face every day that can be upcoming with agents, so I never even go into this because I simply don't know. And this is the major value that the domain experts will bring to any venture. They know exactly what are the pain points, and then they can just tell you as a software engineer, as a builder who knows AI, and then you know how to apply AI to solve this. Just simple about knowing the pain points. And you're right, the two social states. So you either empower this domain experts so that they can build it themselves, or you partner up. And probably the difference between two is just how deep you wanna go. Because I mean, unless UX problem will be solved to such an extent that you truly can crypt whatever complex, which is probably unlikely, then most likely two pathways will exist.
Yes.
For not typical use.
Very true. And I think the gap exists on both sides of the expertise. You mentioned that as an AI expert, you don't know the problems faced by a lawyer on a day-to-day work. On the other side, the lawyer doesn't, he knows very well his problems, but he doesn't know the AI capabilities today and which capability can solve which problems. So this is where the combination makes sense. And we always advise our clients, don't start from technology forward, start from business problems backwards. Let's sit together and write down all your business problems first and then prioritize them by cost impact. And then the ones that can be solved with AI will, and the ones that can be solved with tech but not AI will. But don't prioritize AI just because it's the new buzzword. Prioritize solving your business problems.
Right. Yep. 100%. But I also see another peculiar problem with, especially with people who aren't deep into AI, with not technical, and sometimes with technical users who are just playing around with AI, never went really deep, not AI experts, is they assume that AI cannot solve certain things just because they've heard about it. But I would hear a lot of times people talking about hallucinations without actually deeply understanding what it means and why it happens, what exactly this thing when AI not hallucinates and so on, or even things like privacy of the data and so on. Or causality questions like that AI cannot do causal experience and so on. So this bad rap about AI, I think, is created somewhere in the media and then gets propagated to non-technical users who just take it as this, as the truth, and then it becomes even more difficult to realize that, hey, this problem that does require causal inference or does require whatever can actually be solved no matter what they tell you. So yeah.
It becomes an uphill battle to convince them that it's not true what you read in this non-technical, newspaper. It's not true what you read maybe in September. Might have been true back in September, not anymore. Sometimes I hear people telling me, Alaa, I know you're an AI guy, but I'm not really impressed about this ChatGPT thing. I tried it and it doesn't give a good result. And I say, when did you try it? And they tell me September. And I tell them, first of all, September is 10 years ago. So in AI time. So no. And if you haven't tried the paid version, if you're just trying the free version and the small models, I mean, don't make a judgment call. Go try it first and let's have a conversation. But I like the fact that you're busting some myths about AI. And I think you're the best person to explain and, bust these myths to our audience. So you mentioned three of them. One is hallucination. The other one is cause and inferencing. And the third one is...
what was So yeah, hallucination, causal inference, and just the mere fact that
Rate attacks.
yes,
Gigabytes. Let's take them one by one, and let's bust some myths. Okay, explain hallucinations to our audience, and what level are we in today in terms of our capability to manage and minimize hallucinations?
right. So first of all, the perception that I see oftentimes people have regarding hallucinations that AI just responded something that I as a user didn't expect, and therefore this is a hallucination. Oftentimes, this is actually just the lack of proper instructions and prompting. One trick that I always tell actual software developers oftentimes they would even tell me what this is ask a follow-up question on why the model responded that way. So if the model did respond something that you didn't expect, then maybe indeed confidently lied and so on, right? Which people just call hallucination, and then they stop, and then they're like, okay, this hallucination, AI is just not there. Just ask why you did this, and then oftentimes just by asking the model why you responded in a certain way, you will realize that there are actually gaps in the context that you provided, or contradictory instructions, and this actually worsens as context size increases. I deeply believe that the problem of context size oftentimes is not just the context size itself, but also just contradictory prompts. Whereas as the context increases, the probability that you'll have contradictory instructions increases, and then how we put proper weightage on which instructions to adhere to which percentage points and so on. So if I would have to basically to kind of quickly summarize this, the biggest problem with hallucination is that it's not addressed by just asking why the model is responding in a certain way. Just kind of, okay, so implied, this is just because AI is not smart and so on, and then you just move on to something.
Absolutely. And by the way, we're going to have a longer conversation about the context window and the contradicting instructions probability. But let me weigh in on what you said regarding hallucinations. I always teach in my master classes that hallucinations are getting less and less as models become more and more powerful. And I'm talking about out-of-the-box models. So GPT 4 series hallucinated less than GPT 3 series, and 5 series hallucinated less than 4 series. Same with the Claude series and the Gemini series and all of them. Now, what you get out of the box, you can still do things actively as a user, whether you're a coder or whether you are a non-coding knowledge worker. You can still do things to reduce hallucinations yourself. And I categorize them into 3 categories. Number 1, prompt engineering. Number 2, thinking. And number 3, grounding. So prompt engineering comes first. If you write a good prompt, clear prompt with a good context, you decrease the percentage of hallucination of your AI. And this applies whether you're doing a small task or whether you're studying a large code repo, right? Number 2, it's thinking. If you use a thinking mode and you increase thinking levels up from medium to high, depending on the difficulty of your task, you're asking your AI to reason and to generate inference time compute tokens that allows it to do chain of thought and work step by step through the problem. And this on its own decreases hallucination. And third, grounding. If you attach a trusted PDF, or you tell your AI to use a trusted peer-reviewed journal or a trusted website or URL, again, the AI answers from this context rather from the general weights that it learned during the training phase, and you get a less percentage of hallucinated answer. So if you apply these 3, okay, proper prompt engineering, thinking and reasoning, and grounding, you already decrease your AI percentage of hallucinations. That's what I usually teach my students.
Yeah, 100%, because exactly, if you think about it, most of the time hallucinations happen is because you simply didn't have an information in your context that you were supposed to have, or you got contradictory information in the first place, or just you said whatever question was actually so complex, but you required to just magically give an answer without proper time to analyze, to think, and so on. So that's
AI is not magic. That was I keep kind of telling my friends. Don't think that AI can read your mind. Sometimes people tell you, well, it didn't answer correctly. Okay, have you shown me your prompt? And I see the prompt, and I say, okay, if you didn't ask for what you're expecting, and they tell me, oh, I thought AI will know. I thought AI is smart. Yes, AI is smart. It's not a wizard. It's not gonna read your mind. Just communicate properly. That's what prompt engineering is all about. It's just good communication skill with your AI assistant.
yeah, 100%. Um, should we just ask why and ask AI agent why, and then oftentimes you will see what exactly went wrong. I really compare this, and I even had this in my Twitter hand for quite some time. I think I changed it, but Isaac Asimov had this preferred profession like robopsychology, and in this iRobot, he would write how this robopsychologist, essentially AI engineers in the future, would debug those robots, and they wouldn't be on look into code, or they wouldn't touch, but they would just talk to robots and they would ask questions like, why do you keep circling in a loop bit in a circle on this planet and circle doing task X, Y, Z, and then the robot would be, well, yes, it is my task, but I don't know, I need to do circling and so on. Then they would ask more and more questions until they get to a truth, and they would help the robot to solve these contradictory notions, because of which the robot gets stuck in this case. So they wouldn't touch code at all. And in that point of view, it's definitely visionary. I do think that the future of engineering is going to be something like that. You're not going to touch code you didn't write anyways.
Amazing. It's like a Freudian psychoanalyst. The AI engineers are the psychoanalysts of future LLMs and future robots.
Yes.
Amazing. Let's tackle the second misconception, which is data privacy and data security. Everybody who I talked to today asked me, so if I upload this PDF, are they gonna steal my PDF? Are they gonna show it to my competitors? Are they gonna leak it on the internet? Can you explain this to people? What the answer is to this question?
Yeah, sure. I think it helps to just draw parallels in realizing where your data is stored already today. And if you think about it, none of us probably host our own email box. We have our email in Gmail or in Outlook.com. Yeah, or in Outlook. And we happen to trust that. However, there were definitely conversations like this before when the email was just kind of coming out. Like, can you really trust another technological company with your message equipped or with WhatsApp and Telegram? We couple these private messages already stored somewhere in the cloud.
What's the difference with AI? Why do people think AI is different or trust AI companies less than they used to trust ERP companies or email companies? Why? Is it just psychological?
I think it's just because it's still a new way of interfacing with computers, where you talk to computers instead of kind of like uploading and clicking on the button. I think there's something very solid and deterministic about uploading certain information, clicking a button, or interacting with the interface in such a way, versus talking to an interface that can respond on the same question differently depending on time and so on, which is part of which is by design. They're supposed to do it that way. And I think combination of two, so the novelty, the still novelty of it, and also the non-deterministic nature is what influences the users to trust less in other traditional software systems. However, at its principle, all the same liability and security principles that already apply today for traditional software apply to AI. So for this, there's actually no difference.
Amazing. So let's take a concrete example, and I wanted to explain it to our audience, and we've tried to explain it to the layman's terms. Let's say a company let's say a bank buys an enterprise license from Anthropic for all their employees. Let's say this bank has 1,000 employees. They buy 1,000 seats, $30 a month per user for Claude enterprise license. Now, let's say this bank is in the UAE and there is no Claude inferencing directly in the UAE. So they either have to subscribe to Anthropic through their data center in the US or in Europe, if they have one, I'm not sure, or they have to consume Claude through the Azure subscription in Microsoft in the UAE. Okay, let's take the first example where they have a direct agreement with Claude in the United States, with Anthropic in the United States. This bank is their employees, they are using prompts, so that's data, and they're sharing files, so that's data, and then they're getting answers, so that's data. Where are these three types of data stored, and how do they move, and how secure are they at rest or in motion?
Yeah, sure. So the reality of it is that, first of all, the difference between first or second is just the location of servers.
Yes.
And just virtual geolocation servers, and there is no other difference at all. And everything else that I will describe applies to both, besides the geolocation of local data. So whenever you type a message in ChatGPT or Claude, doesn't matter, it gets sent to the server, and then the server stores it in a database. However, if I were to draw a parallel with email, whenever you type an email and click send, it also goes to the server and then also is stored in the same database. And when I say same database, I mean exactly the same type of database. It's usually a combination of structured data, metadata, like when do you send an email, to whom do you send an email, and so on. Or in case of agents, when did you send a message and to which model you send the message, and so on. And unstructured data, which is text, which oftentimes is converted into numbers so that it's easier to search later. So you can't, it's really hard to scale search over text itself. So oftentimes it's converted into an embedding or vector, which is essentially a set of numbers, which is also just stored already encoded in a database. It's actually interesting. The encoding happens because you want to enable semantic search. So you want to be able to search over the meaning of emails, or in this case, messages. So whenever you ask your code, hey, remember we talked about X, Y, and that, it searches by semantic meaning using those embeddings. But ironically, it also helps with, if you think about it a bit, with privacy, because it's extremely difficult. There are some research papers, but it's extremely difficult to decode the embedding into the original text. So if I took a paragraph and then I created an embedding out of it, which depending on the model, anywhere from 300 to 1,500 numbers, essentially, you don't even need to understand the technicality. So if you think about it, I can encode today, the embedding model can easily take like 10K or more tokens. So 10,000 words I can encode into 350 or 1,500 values of the embedding, which means that I compress all this information. It's really hard to decompress it exactly word for word later. All you capture is just semantic understanding of it. That's why we usually don't use the step for semantic search and so on in factual retrieval and so on. It's a difference. Yes, I'm drifting. Basically, there is no difference in the way the data is stored or else it's
Between whether you're sending an email or whether you're sending a prompt.
yeah.
So how do we guarantee if we're sending a prompt with a PDF, let's say a PDF containing customer information of the bank and financial information. I'm asking Claude to summarize it and to extract insights from it and to do some analysis and give me some dashboard. Okay. My prompt is going to Claude. It's sitting in the database. My PDF is going there. So we both know that the brain itself, the LLM itself, is stateless. It's not going to save anything, but it's the database next to it where my data goes. How do I know that, number one, Anthropic is not taking my data and sharing it with others? Number two, how do I know that Anthropic is not will commit to delete my file when I decide to delete it from my side? And number three, how do they commit to not train the next version of Claude on my data? These are different questions. Okay, what are the answers to these?
I think that the major incentive is just liability, because from technical point of view, they can do all those things just as much as Google can take your email and take a look at what's going on. No matter the encryption methods and so on. Technically, it's not because encryption methods can be broken, they cannot be. It's because the encryption methods in the first place are controlled by the company. So it's just a policy change, and then suddenly nothing is encrypted and you have access to everything. But the legal liability and the incentives just are misaligned. Google will not do it because it's not in their interest at all. Similarly here, the risk of data leakage, if it happens once, it can just destroy your multi-trillion company. It is just against all of the incentives for AI models. The only counter-argument to this is but they can train the data AI on my data and so on. But the reality is that you can train data on email as well, and on all those messages. It's also so it's also data, and you can also train on it. And they too, companies do. But then there is this huge process of first legal, or whether we can even do it in first place, and so on, because just the risk is just too high.
Yes.
And then the second of all is it's not very easy to train on data that you have no context on where this data is coming from and why. Because the general pre-training of on language is already a solved problem. There's plenty of public open data in data to can solve this.
Yes.
What companies right now are competing for is data that has high signal towards solving whatever actual problem, like software engineer.
Yes.
And so on.
Like a domain-based data, real life, today, day-to-day workflow data.
Exactly, and for this you need two things. First, you need to really understand the input, so you really need to understand what we're trying to solve and so on, and then you really need to trust the output, because if output is bad, then
the chain can change.
Yeah, exactly. And the only way to control for both is if you sort the data yourself, which is all these companies are doing, either themselves or via Scale AI and so on. So it's simply impossible to, even if you had a misaligned incentive, which is not the case, but even if you had misaligned incentives, it would be almost impossible to take your average conversations on how do I make breakfast as X and Y and turn it into something useful.
Amazing. This is probably one of the best answers I've got to this data privacy sharing too. So let me summarize what you said to our audience. You're saying, at its face, training or leaking your data or getting access to your data is not a technological obstacle. It's a business obstacle and a legal obstacle. Yes, all these companies that you're sharing your data with have technically the ability to access your data and read your data and do everything about it. They don't do it because of a business reason and because of a legal reason. The business reason is they are interested in keeping their reputation, their customers, and their hundreds of billions of dollars valuation. And if they don't take care of data privacy with their clients, they're going to lose that. Number two, the legal. There are laws around data privacy, and these companies commit to following these laws in the terms and conditions of the enterprise license when you buy an enterprise license from Anthropic or from OpenAI. Very similar to when you buy an enterprise license for Gmail or Oracle or SAP or any other system, right? And you added an extra component saying, even if these companies want to train on your data, their data and AI team won't have good annotated data, a good well-labeled data to be able to add to their training data set. It's not as easy as just stealing anything that people send me and use it for my training data set.
Yeah, exactly.
Amazing. Is there a way to audit that? Are there companies that can audit whether Anthropic or Microsoft or Google or all these companies are in fact training on my data, or are they committing to their terms and conditions of not training on my data?
Mm-hmm. I actually never heard anything about this, about auditing in that matter. The closest thing that they immediately came to my mind, but because that's to do with auditing, but additionally can be also used for that is like generative engine optimization, where you simply ask questions of different providers so that you see what responses come out. So if the responses but then what will happen is that with those responses, the two types, first is grounded responses from the internet, usually being information in the internet that's already public by definition. And then the information that the model itself learned during the pre-training process. And this is the only potential audit where it can be like, okay, so the model did come up with something without grounding, and where did this model get this information from, and so on.
Look, when you were answering this question, you drifted into explaining to us about embeddings and vectors and how they work. And you touched upon the semantic layer. So I would like us to take a deeper dive into this, yeah? Everyone today is interested in creating an AI that understands them, their business, their industry, their country, their day-to-day workflow. And to do that, people have tried multiple ways. The most early way that people tried is RAG, retrieval augmented generation, which was the minimal effort and easiest way to ground AI in your company knowledge. People quickly discovered that this is a very basic and limited approach to build your own AI that knows your business but also remembers your business, because RAG famously doesn't remember and does everything else from scratch. So the discussion today in the market is, how do we create this semantic layer between us and the LLMs that holds all this knowledge and concepts about our business, and we can use it to ask more meaningful questions to AI about our business. Some people say that this semantic layer can be created using, the traditional data platforms. Others are saying, no, we need to move from RAG to knowledge graphs and create these, semantic layers and these ontologies with graphs. And some people like Andrej Karpathy recently said, you know what, it could be much simpler than this. Let's just create an LLM wiki, okay? So there's a lot of talk in the market around what is the best approach to create a semantic layer for your company knowledge base. What are your thoughts on that?
I think that, well, first of all, it's an extremely important problem to solve.
And unsolved yet.
Yeah, and definitely unsolved yet. But I think that this problem existed before AI agents. And the reason why I think so is because if you just let's take as an axiom that the AI agent is just as capable as any human employee. Well, it's not the case today, but let's just take it as a premise. If that's the case, then when you hire a very capable staff software engineer to a company, will the staff software engineer be able to immediately solve all the problems in your company? No. Even though this software engineer knows coding extremely well and very capable. And the reason why is because this engineer doesn't have a necessary context about the company, what are the problems, or what he needs to take into account and so on. So this problem of relevant context existed before AI. And the way we solve it today is we have this onboarding process where during several weeks, the employee gets onboarded. And usually it happens with a peer that teaches, hey, we actually do things here, this and that way, you can access data, X, Y, that, and so. Therefore, I think that this problem of semantic layer of essentially the context about the company is the problem of ingestion of how to table the data that we and the relevant information that we have about the organization, and we push this to an AI agent or other like centralized place so that it's easy to access. Not the problem necessarily of retrieval, because I see all this like knowledge graph versus wiki versus RAG versus file system and so on. To me, it doesn't matter because they're all solving the retrieval problem. Because the retrieval problem is unsolvable if you have nothing to retrieve in the first place. If there's no signal in the data in the first place. That's why you first need to solve how do I take all the relevant information and ingest it in the first place. And I think this is what people should be actually talking a lot more. Because even things like let's integrate Slack, Confluence, and Google Drive and so on and put it all into a, but this is not going to be enough. There's now spoken rules that only employee, also the teams know that you need to extract as well and ingest this. This covers it.
So the problem in your head is not how to most efficiently retrieve a billion tokens. It's how to identify at each step what are the most relevant million token out of these for my current context.
Yes, and also how to take this information in the first place and ingest it. So let's say you already solved this context layer, right? And you have a place where you store all of this information. Doesn't matter whether it's a vector database for RAG or a knowledge graph, so GravityB, or a DQ style file system / knowledge graph. It doesn't matter. Let's say it is a knowledge graph and you already know that it retrieves relevant information really well, right? So imagine that this problem is solved. What I'm saying is that you will still have a huge problem onboarding AI agents simply because this knowledge graph in the first place doesn't have all the necessary signal. So I think we need to talk more about and in the industry solve the problem of how to ingest relevant information into knowledge, not how to retrieve information, but how to put it there in the first place.
Well, I read somewhere on Twitter that the movie Memento is the best movie about context engineering because every day the guy wakes up with zero memory and he has to onboard himself by reading notes he tattooed on his forearm.
Right.
Yeah. Fascinating. All right. We will take a quick break and we will resume. So when you were telling me the story of the different milestones of development for LLMs and Gen AIs and the technology ecosystem around them, you touched upon multimodality, which is a fascinating topic to me. Everybody says that multimodality is the future. GPT-4o was an example of that. the Gemini series, the modern Gemini series, they all claim to be multimodal. If that's the case, if the future of LLMs are multimodal LLMs, why do we still have different unimodal LLMs serving us beyond the unified app? I know if I'm talking to ChatGPT now and I want to create a blog or a text, it's GPT 5.5 that is serving me. But if I said create an image of a dinosaur skiing inside Ski Dubai, it goes to another model that is GPT image dash 2 rather than. So why do I have behind the scene two models serving me if multimodality is the future? Are we not there yet?
As far as I understand, this is mostly the problem of how to serve in the most efficient way. So it's basically the problem of economics. If chips were abundant and so on, that we would have all at once, because simply you can load a bigger model even for image generation and just serve it. But because this is not the case and you're trying to optimize as much as possible, it's more efficient to kind of serve one or the other. However, we are multimodal in terms of the training process for sure already today. So the images and text for Gemini, even videos, it's all being inputted directly during training process and during inference as well. And then for the output, it's really just basically, to summarize, it's an engineering problem. It's not a foundational advanced problem just yet. So, yeah.
So what you're saying is, if I'm going now to Gemini app and I'm doing text to text or text to code, I know that 3.5 Flash is serving me. If I choose create image, I know that Nano Banana is serving me, which is a different model. And if I choose create a video, I know that Veo is serving me, which is also a different model.
Yeah.
But you're saying this is only an inferencing choice to manage compute inferencing and the money behind it correctly. But if compute was not a problem, does Gemini 3.5 generate my text, my video, and my images instead of Nano Banana and Veo?
Yes, exactly. So what I'm trying to say is that if compute wasn't a problem, the most theoretically best way to create a model is the one that both takes as an input everything and outputs everything as well. And the reason why is simply the capabilities, right? You can do all sorts of things. You can put a bunch of audio tracks and then tell it, create now a video based on those audio tracks so that the lip syncing is solved. Right now you need to have a separate model for this. And you can have all sorts of mixes. I mean, it's nothing new. This is how our brain works, right? We take as an input visual information mostly, and then audio as well, and we can output as an audio simply because we just don't have this evolutionary capability of producing visual. Well, I guess you can say like the motor skills. Yeah, we can draw and so on, and that would be the visual of it. But we can definitely dream. And I guess dreaming is essentially the visual of
Is multimodal. Is it multimodal? Do we dream in sounds or do we only dream in visuals? I don't know. We need to ask a psychologist about this.
Yeah, but we definitely have a capability of like outputting a visual picture. Like you can imagine, if you close your eyes, you can imagine things in picture, right? And you can also imagine audio and video. It's not just like 2D. And so on, which means that our brain is multimodal, both input and output. So it makes sense for advanced neural networks to also be that way. But it's not the case because of economics.
Because of economics. So do you see that the future, this economic bottleneck will be solved, and the future is inevitably large multimodal models? Or do you think, because you know what, if it's not broke, don't fix it. Why not just keep it segregated, have different models, uni-model modality models serving you differently, and then the app hiding all of these complexity, and you think you're talking to one big brain behind your app, but you're actually talking to 35. Why change it if it's working?
I think it will be the first, so it will be one model that takes in multimodality input and outputs multimodality output, simply because of signal loss that happens today when I have to transfer from one tool or the other tool. So, for example, if I ask it, here's the PDF of my I don't know, report, and see how it has all these charts and so on. Now create me an image. Depending on how I do this, what can happen is that AI first analyzes the PDF and the prompt and then constructs a prompt, and then takes that prompt and then puts it into an image model, and which means that there will be a loss of information, because I am essentially encoding the model encodes the information from the PDF into text form and then decodes from text to an image. So you have two places where you can just lose the information. But if you directly took the cases, and of course, and you're also adding weights, but if you directly kind of took this PDF as an image, I guess in this case probably the best way, and then directly generated directly did the analysis on this PDF and then generated the image, there is no loss of information. It all happens in one neural network.
So the next big step is inevitably for you large multimodal models that do all of it. Would this be one milestone in the direction of AGI, or do you think AGI will not be solved with current paradigms and we need 2 or 3 new breakthroughs beyond the transformer in order to solve AGI?
So people are talking about world models, which to me is essentially this extreme multimodality of input-output. And they're saying that we need these world models in order to achieve AGI and so on, and like as a next step change towards advancement. And then there's another one that's not a separate, but just kind of another way of achieving it, which is self-improvement. Right? So if you are really good at writing code, you can argue that everything is code, and so you can also create a world model or multimodal by writing lots of code that would solve your daily issues and so on, and create out of world model creation, which is optimization plus the most efficient neural network architecture, and the way it talks to the hardware is all essentially optimization problems, which you can solve through efficient trial and error, which is again another optimization problem. So you can solve it using extremely intelligent AI that can write all those different trials and errors, trials using code. So this is another pathway essential. So instead of just manually trying to build this world model, maybe it makes sense to invest into this self-improving code building model as much as possible. Therefore, I think that if self-improvement, and I do think that it's already is possible with extra intelligence on top of existing model, which can be achieved by just scaling it more. I think it's there is no necessarily any additional advancements that are needed in order to achieve AGI. I think it becomes a problem of just a matter of when, basically, the problem of time and compute.
So scale time, scale compute, and keep increasing the efficacy of the current paradigm, which is an AI that can code better than anyone else. And this will lead to an escape point where AI can recursively develop anything and solve AGI.
Yeah.
Amazing. So you don't think continual learning needs to be solved by humans? You just think humans should keep investing in making coding agents better, and then a recursively coding agent will be able to solve continual learning?
Yeah, exactly. Because if you think about continual, like so what is continual learning? If you are looking at the way humans do this, is that we have short-term, long-term memory, and then we save in long-term memory, which is essentially some sort of a database. We're not going to get what type and so on, but so sort of storage, information storage, and then you retrieve and so on, and then besides the storage, you also have this causal inference, and you understand patterns and so on between like guitar lessons and your lessons in software engineering, and then or something. So you have this constant process of thinking as well. All of this is essentially software engineering problems. So if you optimize to the right target in terms of the metric, then you can get there. That's why in terms of tech, I think we're already there. It's just the major hurdle, which either can be solved by this self-recursion, or humans will help, and then self-recursion will continue. To me, self-improvement is definitely will exist no matter what.
Yes.
It's just about whether we're already at the stage of self-improvement, and it's slow right now, and then the rate of improvement increases as well. There's a second order improvement, or we're not there yet, and then humans need to do something extra. And if the first path, then it's just a matter of time, right? And then if the second path, the only thing that I do think potentially is needed from humans is solve the judgment problem of understanding what is actually good and what is actually not versus bad. This is still something that I see today. Models struggle. Fable doesn't matter. However, there is a clear rate of improvement between GPT 5.5 and Fable, exactly in this judgment problem, with taking into account all sorts of views and points of views, prioritizing those points of views, and understanding what actually matters and what doesn't, and then making this judgment call that feels sound and makes sense.
Amazing. So in your head, better and better coding capabilities for AI is the key to recursive self-improvement and at the limit AGI. So let's zoom in on this, because I keep talking to AI engineers every day, and I watch videos and I read articles and I read blogs, and I get to learn that the biggest problem today with AI coding agents is the problem of managing the context. On paper, Anthropic and OpenAI and Google and all these companies tell us that we give you a context window of 1 million tokens. But in reality, everybody is finding out that this 1 million context window is a lie. Okay? The consensus is that between 0 to 200,000 tokens, your AI agent is coding beautifully, and it's making good code, high quality code, few mistakes. From 200,000 to 400,000 tokens, your coding agent starts making some mistakes, and from 400,000 tokens and beyond, it's sloppy, it's writing slop, it's killing good code, it's writing bad code. And the engineers are calling these the smart zone, the danger zone, and the dumb zone. And every single conversation I'm having today with AI engineers revolves around how to keep the AI coding agent working in the smart zone without crossing to the danger or dumb zone. What do you think about that? Mm-hmm. Are you seeing the same thing? How are you dealing with it? What do you think the best solution for this?
Sure. So this problem definitely exists, and 100%. As the context size increases, it becomes more and more difficult for the model to understand what to take into account and what not to take into account. And if you draw parallel with humans, which code base would be easier to navigate? The one that has one file in it or the one that has 500? And the answer is obvious. So I don't think we should be very kind of like negative towards AI in that matter, where there's almost an expectation that it should perform really well at 1 million, because we don't have the same expectation towards humans. It's way difficult to navigate the code base with millions of lines of code versus the one that has even 200K. It will be much easier. Yeah, it's a huge difference. So I think that this degradation in performance is expected and should be expected. So then, once you understand this, that it's an expectation, then you quickly start to realize that all the same lessons that we have to solve this with humans can be applied here to solve this with AI. So how do we solve huge code bases today, the problem of context of huge code bases today with humans? Well, we do delegation and split of by functionality and so on. And this is where like alt agent system can come into place, or smarter context management comes to place. But really the mental model around this is exactly the same as when you have instead of one engineer trying to somehow keep in mind all those millions lines of code, which is virtually impossible, to several engineers, each engineer really tackling just his whatever part of the feature on the backend side only, not even on front end. And then you have a certain contracts between front end and backend, or service to service that are adhered to and so on. So this is how I think about this rule.
So multiple different people are trying to solve this differently. Some of them, they're using this delegation approach that you mentioned, using sub-agents. So your coding agent will spin up multiple sub-agents, each with their own context window that is more manageable within the smart zone, and they only report what the main agent needs to know, and the main agent reports to you. And other people are creating teams of agents that are parallel, also each with their own context window, but the difference here is they all report to you and you see what they're working on, versus the sub-agents of your main agent. You can't see them, you can see only what the main agent is saying. Have you experimented with these? Do you think one is better than the other, or do you think each one has its use, its time, and its place?
Mm-hmm. My setup is that I have the parallel agents running on different features in separate work trees, so that there's no conflicts ever. And then there's another agent that solves the integration problem between all of those as a separate context. And then when it comes to splitting the code base and so on, this is a good practice in any case, like even if without AI agents and so on, where you have the split by functionality, by features and so on. It's already known techniques. All you have to do is to really map out all of this in your agents MD or so on. In terms of the structure exactly, like do I do sub-agents that all do their work and then report to me, or do I have sort of hierarchy where I have an orchestrator agent that spins up and so on? I mean, I think, again, I draw parallels with organization.
Humans.
Yes, with humans. And then if you do that, then it quickly becomes the question of scale. So if you have a small team of AI agents, probably better if they all report to you so that you can provide feedback as well. Again, that's why I said that the main bottleneck that I see today is judgment. If the judgment was there, you wouldn't be in it at all. But if you need to scale to a point where you have lots of AI agents, and I actually personally struggle to purposely scale whatever work I do in terms of coding to hundreds of agents. because it's essentially like you have a product, a software product, and you need to, and somehow you have a budget to hire 100 engineers. Will you be actually able to tell them what to do? It's a really hard problem, exactly. But if you can somehow, then you definitely need orchestrators and so on. You need managers under you in order to manage smaller teams and so on. So I really think that the organizational structure that's a solved problem, and there are lots of books on this and so on, can be applied to management of agents as well.
Amazing, amazing. You always draw these parallels with the human, whether it's with the human brain, whether it's with human organizations, and it's a good mental model to compare and to learn what worked in human organizations and now in agent organizations. Type, keeping in the spirit of these parallels, you always use analogies with the human brain. And I keep reading a lot these days about this concept of a second brain. Companies like Obsidian allowing you to dump all the articles, the blogs, your notes in one folder, one vault essentially. And then building connections and graph between these different concepts for you to visualize the relationship between your personal information. And this became very popular, and that especially among leaders, the researchers. But then Andrei Karpathy came and proposed this LLM wiki idea, whereby on the lower layer, it's the Obsidian layer where you dump all your data and you curate it and you manage it. But then there's a layer on top of that where you assign an LLM to be a librarian and read all this data and create one page about each concept or each entity, and then link all these pages together like your own Wikipedia. So you have a Daniiar Wikipedia or Alaa Wikipedia linked together, and all the librarian work is managed by LLM. What do you think about this concept of second brain, the concept of LLM wiki by Andrei Karpathy? What are your thoughts on that?
Yeah, and it's really cool. For me, I just trust Claude, and it definitely doesn't do an incredible job at this. So I am hungry for a better system when it comes to like second brain and so on. I am in between Notion and Claude, where Claude is kind of like this integration layer between just raw thoughts dump, and Notion is more structured. But I spend a lot of time manually structuring all of this information myself. So I'll definitely need to look more into more automatic ways of doing this and making it better for myself personally. In general, I think a lot depends here what you're optimizing towards of when you're choosing one method or the other, or how you want to do this. Because if you're optimizing, I'll explain what I mean. Like if you're optimizing for relevance, whenever you ask a question, let's say you ask Claude a certain question, you want to make sure that the response is grounded in certain knowledge and documents. So you're optimizing for this relevance and factual correctness. Cool, this is one thing, and one method will work for you. However, you can also argue that you're optimizing for creativity and something completely unexpected, and then you can't even use the traditional RAG method, because the entire RAG is about getting something that's semantically similar. Getting something that's semantically similar that's relevant to a topic. But what if you're actually optimizing for something unexpected and creativity? An example that I usually provide is, let's say you're an AI engineer like me, but you're asking about a marketing methods, like how to grow product better and so on. So one way is, when you ask it this question, it will ground by searching all other conversations that you did on marketing, and will say, well, you tried X, Y, and Z. Now let's try ABC and so on. But then another way would be to just look into the fact that you're an AI engineer and this is your trait, and suggest things that it wouldn't normally suggest when it would optimize for relevance. For example, why don't you use your AI skills to automate, I don't know, video creation for content, and then try this, because this is something that's not available for a typical marketing person, but available for you.
Yes.
But it has nothing to do with the marketing question. So if you're optimizing for just relevance, then that's one thing. But if you're optimizing for creativity, that's another thing. So the first thing that I kind of encourage people to do is to really pick what you're trying to optimize for, and then depending on this one system or the other is better or not.
Beautiful. It's like the concept of temperature in the LLM assistants, but now taking to a much bigger picture. I always looked at this second brain or LLM wiki as a solution to the knowledge base, personal knowledge base or company knowledge base. I never looked at it from this angle or of maybe we could use the same but optimize for creativity rather from predictability or factualness. Which is amazing that you mentioned creativity, because before we started the recording, I was sharing with you the Bloom's taxonomy by Benjamin Bloom. I learned this from my friend Jeremiah O'Brien. It's a framework for classifying learning objectives according to the level of thinking they require. So this is for human learning. But I think we can start drawing parallels to machines and AI's learning. He said there are 6 levels of learning and obviously intelligence. The lowest level is memory, so remembering, recalling facts or information. The second level is understanding. This is a higher level of learning because now you can explain the ideas or the concepts. The third level is applying. So now you're applying what you learn, this new knowledge, in new situations. Number 4 is analyzing. This is when you're able to break down information that you learn into small parts and then examining the relationships between. Number 5 is evaluating. This is when you're able to make judgments based on evidence. And number 6, which is the top of the pyramid, is creating. This is when you're able to produce something new by combining the ideas that you learn. Yeah? What do you think about this Bloom taxonomy? And do you think we can draw parallels and mirror it in AI agents and machines?
Yeah. So as I was saying before, to me, right now we are at the judgment stage where models sometimes are good at judging and other times are still really bad. So to me, as soon as we'll be able to solve this, the art of creativity will be solved. I really do think that the judgment is probably the most important part of creativity, of understanding what's actually good or bad. And we talk about how this artists, music artists or whoever, is probably the most creative type of job you can think of. Still, it's a routine where every day they work, they come up with different tunes, with different songs, they try things and so on. And only if you become very popular or just loved by their audience, doesn't matter whether popularity or not. And I don't think that there's necessarily a formula, but rather trial and error. So yeah.
I love it. So what you're saying is we have solved the first 4 layers and we're trying to solve layer 5 now. So remembering is obviously solved in technology, in machine. Understanding, which is level 2, applying level 3, and analyzing level 4. Do you think AI agents can really understand, apply, and analyze? Because we're giving them the reasoning features that infinite can't compute. Do you think this maps to understanding, applying, and analyzing, and we're only now stuck at judgment calls, step 5?
Yes, I think so because just like I said, memory this obviously already solved. And then if you think about the reason why RAG exists in the first place is because the G in RAG, the generation step, is the understanding part. So you retrieve the information from memory, and now you need to make sense of it. Like, well, how do I use it given a certain context? Which means that you need to understand it. So understanding is solved just because we have this G in RAG.
Yeah.
So just because of this, understanding is definitely solved. And then the applying part is also arguably solved by definition of agents. The entire difference between an agent and a simple chatbot is that agent can take actions, so that it can apply whatever knowledge it has, whatever understanding of the problem. So because agents already exist, then applying also exists. And because agents can solve problems, they can write coding that actually works and so on, right? And then when it comes to analysis here, to me, it depends on the complexity of the analysis and the amount of feedback loop needed. Because if feedback loop is a verifiable outcome, so something that you can definitely
Judge good or bad and do my LVR, right? Reinforcement learning by verifiable results.
Exactly. So if you can put a definitive number on it, so a quantitative number, then it's the end result.
Like math, coding, games.
Yeah, exactly. And then there are plenty of examples of how we solve this, right? AlphaGo, AlphaZero, and so on, how we solve this analysis part, because they're all verifiable outcomes. You will never debate whether one side has won at chess or not. Like it's a verifiable outcome. But if you're thinking about the analysis where it is still debatable, then I think we blended to this judgment call. And I do think that we're still not there yet. So.
Amazing. I wanted to also ask you about, the race to all these models getting better and better. It's not only the American labs and the closed proprietary labs driving the frontier. It's also the open source labs. I'm following closely what Z.ai are doing with their GLM series, what Moonshot are doing with their Kimi series, what DeepSeek are doing, what Alibaba are doing with Quan. Even Google released Gemma 31D, and it's very capable. So let's talk about like the state of the art one, something like Z.ai GLM 5.1 or 5.2 series. It's trailing Claude Opus step by step. It's behind it, but not very far behind it. What do you think the future of open source models? Do you think we will achieve parity? Do you think we'll achieve flippening? Do you think it's inevitable that OSS models will reach the same level of proprietary models? Or do you think proprietary will always have few month advantage?
I think that so today we're definitely the open source models are definitely behind, and in terms of the benchmarks, I know that GLM 5.2, right? I think there is the latest model, is fairly close in terms of benchmarks. However, there are some other benchmarks where they're still quite behind. I forgot the name of Provo Vision, and then there's some other reasoning related. But I think my fear is that it's not that they're behind a couple of months and so on. It is the fact that there's a second order improvement. It's not just first order difference. The problem is that achieving the second version that's much better than the first version is much faster. It's much faster to go from Fable 5 to Fable 6 than to go from
Opus to Fable 5.
Yes, than to go from Opus to Fable 5. And this is a huge problem for open source models, because yes, today you are behind by 2 months, but tomorrow you will be behind by much more, simply because it's much easier to get from Fable 5 to Fable 6. So then it's the question of how quickly can you get to that point of self-improvement. And this is what concerns me a lot. I am a big believer in open source models. I think it's important for multitude of reasons, but to me the most recent one is the fact that Fable 5 was just restricted from everyone. But the reasoning behind the restriction wasn't like, let's restrict it for everyone because it's too dangerous. The reasoning was the proprietary kind of nature of it that on a country level, right? And this is super scary. If before AI sovereignty was kind of a nice to have type of thing, I feel like right now it becomes a must have. And the only way to, the most efficient way to do this is to start with open source models and then try to build up something of your own. And now GPT 5.6 came out and it's also not available for the same reasons.
Terra and Luna.
Exactly. And since models will be only improving, you can safely assume that everything else will also have some sort of restrictions and so on. And it goes to a point that even Fable 5, but even when it was released, it famously has this LLM baked into the model, LLM guardrails against providing the knowledge on how to create a better LLM. So if I'm an AI engineer who wants to build my own LLM and wants to improve it, and I want to use Fable for guidance and for writing code, I will ensure it. Yes, it will just tell me, and this is extremely scary because one thing is outright not telling use something, or the other thing is potential deceiving. Or you can just confidently route someone towards a path that you know will fail. So exactly. So because of this competition, the incentives might be on the wrong side, and this is what worries me. But when it's open source and open weights, because everything is transparent, it will be impossible to create such and manipulate in such a way. That's why I'm a big believer in open source, and I hope it will work out.
Keep working on the open source, and shout out to all the developers in the world who keep up with all of this technology by closely, trailing the state-of-the-art models with OSS technology. We're getting towards the end of our podcast, and I would like you to tell us more about Mascara, about your baby. How did you start Mascara? What is the objective from it, and where is it now?
Mm-hmm. Yeah, so Mascara is a platform where people can build background AI agents. So what is background AI agent? Right now, all of the interactions that we have with AI agents today is what I call on-demand interactions. So you have a question, you ask a question, or you have a task, you give a task like write me X and Y Z code that does ABC. So it's an on-demand interaction. However, if you again draw parallels with what we do day to day, you realize that a lot of work we do just on the background by ourselves. We don't interact with anyone. We have lots of meetings, maybe sometimes too much, but oftentimes we just have work that we do by ourselves. And this is something that we can potentially outsource as well to background agents. And some of the examples would be, for example, an AI agent that helps you gain more followers on Twitter. One way to do this is to work with Claude and with ChatGPT and so on, and to be like, okay, do research on AI topics and tell me what I should comment on because it's trendy and so on. Now come up with drafts, and then you iterate, and then you post. Or the other way is to just completely let go, let AI do this. And Mascara is built in such a way to handle exactly this type of use cases, where it handles everything on the background. AI agent makes those judgment calls and then makes whatever workflow you're working on this automatic.
I know that AI engineers call this AFK, away from keyboard.
Yeah.
You're taking AFK and you're doing it as a service. AFK as a service. Brilliant, brilliant. Listen, I wish you the best of luck with this. We also, on every episode, my assistant Layla usually asks a question to our podcast guests. Here, so let's see what she'll have in. Hey Layla, how are you today?
Yeah, I'm right here, ready to roll. What's on your mind?
So let me show you. As you see, we are in the podcast studio, and this is my guest for today, Daniiar. Say hi to Daniiar.
Hey, Daniiar, you look pretty relaxed and ready for some good conversation. I can tell this is gonna be a fun episode.
Oh, Layla, we're at the end of the episode. That's why we're calling upon you to ask your questions. So, Daniiar is an AI guru. He is one of the engineers at the forefront of AI engineering development today. He's experts in LMs, in agents, in context engineering. I want you to dig deep down and ask him the most, original, thoughtful question that you can ask an AI engineer.
All right, Daniiar, here's one for you. If we imagine AI agents becoming as commonplace as smartphones, what's one thing you'd want them to do that no one's talking about yet? Something that would make people go, oh, why didn't we think of that before? Let's get futuristic, but practical.
I mean, this is obviously a very great question and something that I'm contemplating a lot about. And one of the incentives behind Mascara, as I said, I do think that we don't talk enough about what type of work can we today, not in the future, but today, outsource fully to AI agents without thinking about all the risks and so on. And I do think that there are all sorts of applications that that AI agents can take on fully, just because the amount of risk is actually low. And this depends from person to person. For example, you can potentially open up 100 different Twitter accounts and then do posts and then see which one does well or not. And the reason why it can be low for you, or for me, for example, as an AI engineer in terms of risk, is because my livelihood doesn't depend on this. Like if all 100 fail, fine, but if at least one of them will succeed and will get a certain number of followers, that's awesome. It becomes a real thing, and then I can step in and make sure that I actually spend time on this or not. And I think this is something that we don't think when we talk about AI agents. We only talk about optimizing the existing workflows that we already know of and that we are already working on. But we are not thinking about what if instead of thinking about on how to reserve, I don't know, a table in a restaurant, we're thinking about how to call 1,000 restaurants and then find out like this second order in terms of scaling and also outsourcing work that we are not doing today at all because we just don't have time. So instead of thinking about how to outsource high priority items, why don't we outsource something that we didn't even think of at all?
Low risk, high reward.
Exactly.
In all situation, low downside, high upside situation. Leia, what do you think about this?
Honestly, I love it. That's the kind of out-of-the-box thinking that makes AI exciting. Plus, if one of those AI agents scores a hit, you're basically automating serendipity. Now that's futuristic.
Amazing. Automating serendipity. Thank you, Leila. And seriously, if anyone is an out-of-box thinker, it would be you, Daniiar. And I always enjoy our conversation, whether it's over coffee, whether it's over Zoom, and today in front of the cameras. As I promised you, it will just be a regular, Daniiar Alaa conversation. I know our audience will get a lot of value from it. I hope you enjoyed it as much as I enjoyed learning from you, and we'll definitely do it again.
Thank you. Thanks a lot. I definitely really enjoyed it. As always, it just felt like a one of our conversations. So it was thanks for having me.
Absolute pleasure.